Hello there, and welcome to Sleepy Science Vault. Every morning, without thinking about it, you step into something you can never step out of. You wake up, and time has already moved. The night is gone. A new set of hours waits in front of you. You didn't choose to enter this stream, you were born into it, and it has been carrying you forward ever since. We rarely stop to ask what time actually is. It feels so obvious, so present, so completely woven into everything we do, that questioning it seems almost unnecessary. And yet, the moment you try to define it, really define it, it becomes one of the most elusive things the human mind has ever reached for. Time is what keeps everything from happening at once. That might sound like a joke, but it's one of the most quietly profound things ever said about it. Think about what the world would look like without time. Every event in your life, your birth, your childhood, this very moment, every conversation you've ever had, existing simultaneously, with no before and no after. No sequence. No story. Just an infinite, incomprehensible pile of everything, all at once. Time is the thing that prevents that. It is what separates one moment from the next, and in doing so, it makes experience itself possible. Because of time, there is such a thing as later. That word, later, is something we use dozens of times a day without realizing how strange it is. Later means, this has not happened yet, but it will. It implies a future. It implies that the present is not the end. We make plans, we set alarms, we say, "I'll do it tomorrow," and underneath all of that is a quiet faith that time will continue, that later will actually arrive. Time is also inseparable from change. In fact, you cannot have one without the other. If nothing changed, not a single atom, not a single thought, not a single photon moving through space, would time still pass? Some philosophers say no. They argue that time is not some invisible river flowing whether or not anything moves. Instead, time might simply be change. It might be what we call the fact that things are different now than they were before. This connects time to something even deeper, causality. The idea that one thing leads to another. That causes come before effects. That you cannot unring a bell. Time gives causality its direction. It is the reason why, when you drop a glass, it falls and shatters, and not the other way around. We have never once observed a broken glass reassemble itself on the floor and leap back into a hand. Time moves in one direction, and causality flows with it. The two are almost the same thing, seen from different angles. And then there is motion. Motion is perhaps the most visible proof that time exists. For anything to move, a planet, a bird, a single electron, it must occupy one position, and then another position, at a different moment. Without time, there is no different moment. Without time, there is no movement at all. The universe would be utterly, perfectly, permanently still. Every river frozen. Every heartbeat suspended. Every breath held forever in the same instant. We think of a moment as something small and simple, a point in time, a snapshot of now. But a moment is actually something quite delicate. It is the edge between what has already happened and what has not happened yet. It is paper thin. The instant you try to point at it, it has already slipped into the past. Right now, as you hear these words, each syllable is becoming a memory before the next one arrives. The present is always escaping. It is always becoming history. And somehow, we live there, in this razor-thin, constantly vanishing instant called now. This is perhaps why waiting feels so strange. Waiting is what happens when you are aware of time passing without feeling like you are moving with it. You sit in stillness, and yet time continues, second after second, emptying into the past. Waiting makes time visible in a way that busy moments don't. It stretches it. It makes you feel its texture. And in that way, waiting might be one of the purest experiences of time that we ever have. And now, that word we use so casually, is one of the most fragile concepts in all of existence. It has no thickness. It cannot be held. The moment you say the word now, that now is already gone, replaced by another now, which is also already gone. You are never quite standing still in time. You are always moving through it, even when you feel like you're not going anywhere at all. Time orders events. It gives your life a shape, a beginning, a middle, and eventually, an end. It is what makes a story possible, what makes memory possible, what makes tomorrow possible. It is so fundamental that we built entire civilizations around measuring it. And yet, for all that, for all the clocks and calendars and carefully counted seconds, we are still not entirely sure what time is. We know how to use it. We know how to measure it. But understanding it, truly understanding it, remains one of the great open questions of human thought. That question is worth sitting with tonight. Not with urgency. Not with any need to solve it. Just with the quiet, comfortable awareness that you are moving through something mysterious, something ancient, something universal, and that every living thing that has ever existed has been carried along by the very same current. There is a version of time that exists in physics textbooks, measured by atomic clocks and written in mathematical equations. And then there is the version of time you actually live in, the one that drags on a slow afternoon and vanishes entirely on a perfect evening. These two versions are related, but they are not the same thing. The time you experience is filtered through something far more complicated than any clock, a human mind. Memory is where experienced time begins to take shape. Without memory, time would have no structure for us at all. You could not feel the difference between yesterday and today. You could not recognize that this moment is different from the last. Memory is what stitches moments together into something coherent, into a life that has a past, a present, and a sense of direction. Time gives memory its order, and memory gives time its meaning. They are built for each other. And this is precisely why you cannot remember the future. It sounds obvious when you say it out loud, but the reason is worth sitting with. Memory works by storing what has already happened, events that have already left their mark on the present. The future hasn't happened yet. It has left no mark. There is nothing to store. So the mind, for all its extraordinary power, is permanently locked out of tomorrow's experiences until tomorrow actually arrives. You can imagine the future. You can plan for it, fear it, hope for it. but you cannot remember it. That asymmetry is one of time's most defining features, and it shapes almost everything about how we think and feel and live. Perception and memory together create something strange. They don't just record time, they distort it. Think about a childhood summer. In the living of it, days may have felt ordinary. But looking back, that summer might feel enormous, full and rich, and somehow much longer than a single summer should be. Meanwhile, a recent year might feel like it passed in a matter of weeks. Time in memory doesn't scale proportionally to the clock. Periods filled with new experiences feel longer in retrospect. Periods of routine feel compressed. Your memory is not a recording device. It is an editor, and it changes the runtime of your life as it sees fit. Psychological time, the time you feel rather than measure, is endlessly elastic. An hour in a waiting room and an hour doing something you love are technically identical. The clock moves at exactly the same rate during both. And yet no experience of the two feels remotely similar. Under stress or boredom, time slows to something almost painful. In a state of deep focus or genuine joy, it disappears. Some people describe being so absorbed in music, or a conversation, or a creative project, that they look up to discover that hours have passed without them noticing a single minute. The clock kept ticking. They just weren't there to hear it. Here is something quietly remarkable. Right now, in this very moment, you are not actually experiencing the present. You are experiencing the very recent past. The signals from your eyes, your ears, your skin, all of that sensory information takes time to travel to your brain, and your brain takes additional time to process and assemble it into a coherent experience. The result is that your conscious awareness of now is running approximately 80 milliseconds behind actual, physical reality. Your brain compensates for this beautifully, stitching everything together so seamlessly that you never notice the delay. But the present you are living in is always, ever so slightly, a constructed memory of a moment that has technically already passed. You are, in a very real sense, always living a little bit in the past. And you can only ever have one now at a time. This seems trivially obvious, but consider what it means. You cannot be fully present in two moments simultaneously. You cannot relive yesterday while genuinely experiencing today. Every now excludes every other now. The moment you are standing in is the only one available to you, and the moment you step out of it, even just in thought, drifting into memory or worry or anticipation, you are no longer quite here. This is something meditators and philosophers have noticed for thousands of years. The present is singular. There is always only one of it, and it is always yours to either inhabit or let slip by unnoticed. Your own biology has a hand in shaping how time feels. The speed of your internal clock is not fixed, it changes with body temperature, with age, with the chemicals in your bloodstream. When you have a fever, time often feels slower, because your metabolism is running faster and your brain is processing more cycles per second of real-world time. Certain states of intense fear or extreme focus can produce the same effect, the famous sensation of time slowing down in a crisis, where a few seconds seem to unfold with extraordinary clarity. Your nervous system is not a passive observer of time. It is an active participant, bending and reshaping the experience of it moment by moment. And then there is aging. One of the quiet cruelties of time is that it seems to accelerate as you get older. When you were very young, a single year represented a significant fraction of your entire life. A year was enormous, full of firsts, of novelty, of things you had never seen or felt before. As you age, each year becomes a smaller proportion of the total. And because the brain encodes novel experiences more richly than familiar ones, years filled with routine leave thinner memories. They compress. They seem to shrink. This is why childhood summers feel eternal in memory and why decades can feel, in retrospect, like they moved too quickly. Time doesn't actually accelerate, but the experience of it does. And for many people, there is something in that which feels quietly, undeniably unfair. Time is not symmetric in human experience. The past and the future don't feel like equal territories. The past is fixed, known, a country you can no longer enter but can at least remember. The future is open, uncertain, and somewhat frightening precisely because of that openness. We tend to fear future pain more than we regret past pain of the same magnitude. We tend to look forward to future pleasures less intensely than we remember past ones. The emotional weight of time is not evenly distributed. It tilts. It leans. It favors some moments over others in ways that have very little to do with logic. And perhaps most profoundly, time is entangled with identity itself. You are not the same person you were 10 years ago. Your cells have been replaced, your beliefs have shifted, your priorities have changed. And yet there is a thread, a continuous sense of being you, that runs through all of those versions. That thread is made of time. It is made of memory and continuity and the unbroken chain of moments connecting who you were to who you are. Without time, there is no self to speak of. There is no becoming, no growth, no story. Identity requires duration. It requires the ability to look back and say, I was there, then, and now I am here. You are, in a very deep sense, a creature of time. Not just because you age, or because you die, but because the very thing you call yourself only exists because moments have followed one another in a particular sequence, and you have lived through all of them. Every version of you that ever existed did so inside time. And the version of you that exists right now, here, in this quiet moment, at the end of this particular day, is simply the most recent one. That thought doesn't need to be heavy. It can be quite gentle, actually. You are a being who moves through time, shaped by it, sometimes confused by it, occasionally in love with it. And there is something strangely comforting in knowing that every human being who has ever drawn breath has felt exactly the same thing, that mysterious, ungraspable sensation of time passing, and the life they are living moving forward with it. Long before any human being invented a clock, life already knew what time it was. Deep inside almost every living thing on Earth, from the smallest bacterium to the largest mammal, there is a biological clock. A molecular rhythm, ticking away without any instruction from the outside world. It knows when to be alert and when to be tired. It knows when to release certain hormones, when to lower your body temperature, when to prepare your body for sleep. These internal clocks are so precise, so ancient, and so universal that scientists believe they evolved somewhere around 3.5 billion years ago, almost as old as life itself. Time is not something living things learn to deal with. It is something life was built around, from the very beginning. This is why the sun still affects you even when you spend a day entirely indoors. Your circadian rhythm, that roughly 24-hour internal cycle, is synchronized to light, and it runs whether you are paying attention to it or not. Disrupt it for long enough, through shift work or travel across time zones, and the effects are felt throughout the entire body. Sleep suffers. Mood changes. Digestion, immunity, concentration, all of it shifts. The body is not indifferent to time. It is organized by it, from the inside out. Aging is perhaps the most visible way that time writes itself onto a living thing. Every organism that has ever lived has aged. Cells divide, and with each division, small errors accumulate. Proteins that once folded perfectly begin to misfold. Tissues that once repaired themselves quickly begin to slow. This is not a malfunction, it is the nature of being a physical system operating across time. Things change. Entropy increases. And in biological systems, that gradual accumulation of change is what we call aging. Time does not damage us out of cruelty. It simply continues, and we are changed by the continuing. But aging is not only loss. It is also the mechanism by which something extraordinary becomes possible, growing up. A child becomes an adolescent. An adolescent becomes an adult. With each passing year, the brain develops new capacities, new emotional depth, new ways of understanding the world. The prefrontal cortex, the part of the brain responsible for judgment, empathy, and long-term thinking, does not finish developing until a person's mid-20s. You cannot rush it. You cannot compress it. It requires time, in the most literal neurological sense, to come fully online. Growing up is not just a social idea. It is a biological process that happens on time's schedule, not ours. Learning, too, is fundamentally a process that belongs to time. You cannot learn a language in an afternoon. You cannot understand mathematics by reading a single page. Knowledge builds on itself, layer by layer, session by session, return visit by return visit. The brain learns through repetition and reflection, through sleep that consolidates memories, through the gradual strengthening of neural pathways that are visited again and again. Time is not just helpful for learning. It is structurally required. The brain needs duration to change, and learning is a change in the brain. This is also why practice improves skill. It is one of the most reliable facts about human development, and one of the most patient. A pianist who practices scales for years develops a relationship between mind and muscle that cannot be shortcut. A surgeon who has performed thousands of procedures operates with a fluency and confidence that no textbook can install in a single reading. Expertise accumulates. It sediments. Every hour of deliberate practice leaves a slightly different brain than the one that began it, and over thousands of hours, those differences compound into something that looks, from the outside, like extraordinary natural talent. but it is almost never that. It is almost always time, applied with consistency and intention, over a very long period. And then consider music. Of all the things that time makes possible, music might be the most purely beautiful. Music only exists in time. It cannot exist in a single frozen moment the way a painting can. A piece of music is, by definition, a sequence, notes following one another, rhythms unfolding, silences creating space between sounds. Take away time, and a symphony becomes a single incomprehensible chord, all notes sounding at once. It becomes noise. The reason music moves us, the reason it can make your chest tighten or your eyes fill or your foot start to tap without your permission, is entirely because of its relationship with time. Anticipation. Resolution. A melody that departs and returns. A rhythm that your body cannot help but follow. Music is time, made audible. Cinema works by the same principle. A film is nothing more than a very large number of still images, shown in rapid sequence, at a rate carefully calibrated to create the illusion of continuous motion. Your eye and brain, moving through time, interpret a series of frozen photographs as a living world. Without time, without the sequence, without the duration, a film is just a stack of pictures. It becomes a story only when it is allowed to unfold, frame by frame, moment by moment. The same shot means something completely different depending on what came before it and what comes after. Context in film is always a function of time. Storytelling itself is perhaps the oldest human technology, and it is built entirely on time structure. Every story, from the simplest folk tale to the most intricate novel, has a before and an after. Things change. A character begins in one state and ends in another. Events cause other events. There is a sequence, even when a story deliberately scrambles that sequence. It relies on your understanding of time to create meaning from the scrambling. We are narrative animals. We understand our own lives as stories. We remember the past as a kind of story we tell ourselves. In every story we have ever told, in every culture across all of human history, has depended on time to give it shape. History is storytelling applied to the collective. It is the record of what happened, in what order, with what consequences, for whom. Without time, there is no history. There is no before and after. There are no consequences, because consequences require a cause to come first. History is the accumulated record of time passing through human civilization, leaving its marks. Every empire, every invention, every war and treaty and discovery, all of it is arranged along a single timeline, connected by the simple, powerful logic of one thing leading to another. But time is not experienced the same way everywhere. Different cultures have organized their relationship with time in profoundly different ways. Some cultures are what anthropologists call monochronic, focused on one thing at a time, punctual, linear, with a strong sense of schedule and sequence. Others are polychronic, more fluid, more flexible, less governed by the clock and more by the rhythm of relationships and events. Some languages don't mark the future tense in the same way others do. Some traditional cultures divide time not by hours and minutes but by seasons, harvests, or ceremonies. Time is universal, but the human relationship with time is cultural, shaped by language, geography, religion, and history. And in every culture, time is narrative. We mark it with stories, with birthdays and anniversaries, with funerals and festivals, with the stories we tell ourselves about who we were and who we are becoming. Even a year is a story. It begins in winter and passes through spring and summer and autumn and comes around again to the cold. We celebrate the turning of the year because time cycling and time passing are both things that human beings have always felt deserve to be acknowledged. There is something in us that understands, instinctively, that time is not just a background condition. It is the medium in which every human life is lived, and every human story is told. We are, all of us, historians of our own experience, keeping a running account of the moments we have moved through, and the ones that have moved us. That record, imperfect and selective as it always is what we carry with us as we continue forward. It is the shape of a life. And it only exists because time made it possible to have a past worth remembering, and a future worth imagining. Something quietly extraordinary happened when human beings stopped simply living inside time and began trying to measure it. For most of human history, time was not a number. It was a feeling, the warmth of morning sun, the angle of afternoon light, the rhythm of hunger and sleep, the slow turn of seasons. People organized their days not around hours but around events. You woke when it was light. You worked until it was dark. You planted when the ground thawed and harvested before the cold returned. Time was real, but it was not yet a system. And then, gradually, it became one. The first measurements of time were borrowed from the sky. The day, one rotation of the Earth, was the most obvious unit, because it announced itself with light and darkness every single cycle without fail. The month came from the moon, whose face changed on a reliable schedule, filling and emptying in roughly 29.5 days. The year came from the sun, or rather from the Earth's journey around it, which repeated the seasons with enough regularity that ancient observers could track it, predict it, and eventually build entire calendars around it. These were not arbitrary inventions. They were observations. Nature was already keeping time. Humans simply learned to read it. But here is something worth pausing on. The way we divide and label time is, to a significant degree, a human convention. The 7-day week, for instance, has no astronomical basis. There is no celestial cycle that produces exactly 7 days. It is a cultural artifact, one that spread through history via religion, trade, and the sheer convenience of having a shared rhythm for work and rest. The hour has a history too. The ancient Egyptians divided the day into 12 parts and the night into 12 parts, which gave us 24 units, but those units were not equal in length. Summer hours were longer than winter hours, because they were calculated as fractions of daylight, and daylight itself changes with the seasons. Equal hours, the kind that a clock reliably produces, are themselves a relatively recent invention, one that required mechanical precision to make practical. The idea that noon is the same length of time as midnight, that Monday is the same duration as Friday, that every hour ticks through exactly 60 minutes regardless of the season, the weather, or what is happening in any individual life, this is a convention. A deeply useful, civilization organizing convention, but a convention nonetheless. In a meaningful sense, the clock did not reveal time. It standardized it. And time as a resource, that is perhaps the most modern idea of all. The notion that time can be spent, saved, wasted, invested, or lost is not a timeless human intuition. It emerged gradually and accelerated sharply with industrialization. When work moved into factories with fixed shifts, and wages were paid by the hour, time became something that could be converted into money and money into time. That exchange transformed how people related to their days. Suddenly, an idle hour was not just a quiet hour. It was a cost. The phrase "time is money" is often attributed to Benjamin Franklin, writing in the 18th century, and the fact that it has remained in common use ever since says something significant about how deeply that idea took root in modern life. Deadlines are one of the most direct expressions of time as a resource. A deadline is a point in time at which something must be complete, not because the universe demands it, but because a system of human activity requires it. Deadlines create accountability. They structure effort. They transform an abstract future task into a present urgency. Without them, many things that need to happen simply wouldn't, or would arrive too late to be useful. The deadline is time made into pressure, and pressure made into action. It is one of the ways that human beings have learned to use the forward movement of time as a motivating force rather than just a passive backdrop. Being on time is another concept that only makes sense once time has been quantified and shared. It requires a common reference point, a clock that everyone agrees on, a system of hours and minutes that means the same thing to everyone in the same place. For most of human history, this was difficult or impossible. Different towns kept different times, based on their own observations of the sun. Two cities just a few dozen miles apart might disagree by 10 or 15 minutes on what time it actually was. This was mildly inconvenient until railways arrived. Trains needed timetables, and timetables required consistency across distances. It was the railways, not philosophers or scientists, that forced the standardization of time across regions, and eventually led to the global system of time zones that the entire world now uses. The pressure of punctuality, at a civilizational scale, reorganized the clock itself. Cities made this even more visible. The rush hour, that twice-daily surge of human movement through urban space, is one of the most striking examples of how a shared time system shapes physical behavior. Millions of people, operating under the same clock, all choosing to travel at approximately the same moments, creating patterns of congestion and rhythm that any city dweller knows intuitively. Rush hour is time made visible in traffic. It is what happens when human schedules synchronize at scale. The city breathes in and out according to the clock, and that rhythm, morning and evening, work and return, is one of the defining experiences of modern life. Underneath all of these human systems, though, the physical reality of time continues unchanged. The Earth spins on its axis, as it has for 4.5 billion years, completing one rotation every 24 hours with a reliability that no mechanical clock has ever quite matched. This spin is why we have days and nights. The side of the Earth facing the sun is in daylight. the side turned away is in darkness. And as the planet rotates, that line between light and shadow sweeps slowly across continents and oceans, carrying morning and evening with it around the globe. Right now, on the opposite side of the Earth from where you are, it is either day or night, the inverse of whatever you are experiencing, and both of those realities are happening simultaneously, on the same planet, at the same moment. The Earth also tilts. Its axis leans at about 23.5 degrees relative to its orbit around the Sun, and it is this tilt, not distance from the Sun, that gives us seasons. In summer, your hemisphere leans toward the Sun, receiving more direct light for longer hours. In winter, it leans away, and the days shorten. The planet traces this orbit year after year, and the seasons follow in the same sequence, reliably, predictably, as they have for as long as complex life has existed on this world. Spring, summer, autumn, winter, returning in order, every time, without exception. The seasons are time made visible in temperature and light and the behavior of living things. They are the year, expressing itself. And so human civilization has built its sense of time on top of all of this, on the spin of a planet, the tilt of an axis, the reliable passage of the Earth around its star. We took those astronomical rhythms and refined them, divided them, named them, and encoded them into calendars and clocks and schedules and deadlines. We turned the raw motion of a solar system into something that fits on a wristwatch and organizes a workday. It is a remarkable thing, when you consider it. The same force that tells a flower when to bloom and a bird when to migrate is also the force that tells you when your meeting starts. The clock on your wall is ultimately a highly processed version of the same information the sun has been broadcasting to this planet for billions of years. We just learned, slowly and ingeniously, how to read it more precisely. And in reading it so precisely, we changed our relationship with it, perhaps more than we always realize. We gained efficiency in coordination and the extraordinary ability to synchronize the activities of billions of people across the surface of the planet. And we traded, in some small way, the older, softer experience of time, the one governed by seasons and sunlight and the natural rhythm of a body moving through a day, for something faster, more demanding, and considerably harder to ignore. Both versions of time are real. The clock and the sun. The deadline and the season. The scheduled hour and the long, unhurried afternoon. We live inside all of them at once, which is perhaps why time so often feels like it is pulling in more than one direction. For most of human history, time was local. It belonged to wherever you were standing. If you lived in a village, time was the position of the sun above your particular patch of ground. Noon was when the sun reached its highest point in your sky, not in the next town, not in the capital, but here, above you, where you stood. Nobody needed to agree with anyone far away, because almost nobody traveled fast enough for the difference to matter. Life was local, and so was time. Then the world began to accelerate. Ships crossed oceans. Empires expanded across continents. And the need to coordinate time across vast distances became not just a convenience but a matter of survival. A ship navigator in the open ocean, with no landmarks in sight, could determine latitude, how far north or south they were, by measuring the height of the sun or stars. But determining longitude, how far east or west, required knowing the exact time back at a fixed reference point, usually the home port, and comparing it to the local time at sea. Every 4 minutes of difference represented 1 degree of longitude. To know where you were in the world, you had to know what time it was somewhere else. Precise timekeeping, at sea, was the difference between arriving safely and running onto unseen rocks in the dark. This is why the development of the marine chronometer in the 18th century was considered one of the most important technological achievements of its era. A clock that could keep accurate time through months at sea, through temperature changes, through humidity, through the constant motion of waves, gave navigators a fixed reference point they could carry with them anywhere on the ocean. It gave empires the ability to move ships, goods, armies, and authority across the planet with far greater reliability than before. The clock did not just measure time. It extended power. The same logic eventually forced the creation of time zones. As railways spread across continents in the 19th century, the patchwork of local times became genuinely unworkable. A train journey of several hundred miles might pass through dozens of towns, each keeping its own version of noon. Timetables were impossible to standardize. Collisions happened because different stations were operating on slightly different clocks. The solution, dividing the globe into 24 zones, each 1 hour apart, each tied to a standardized meridian, was adopted gradually and sometimes reluctantly. People resisted, because setting the clock to a government-mandated time rather than the sun felt like a strange kind of imposition. In a sense, it was. Time zones are a political and practical agreement layered over an astronomical reality. They made coordination possible, but they are not what the sun would choose. Time zones also mean that the same moment in physical time has a different name depending on where you are. When it is midnight on one side of a time zone boundary, it is 11 in the evening on the other, even if those 2 points are only a few miles apart. The international date line takes this further. Cross it in one direction and you gain a day, cross it in the other and you lose one. A traveler who crosses it at the right moment can, technically, experience the same calendar date twice, or skip one entirely. The date is not a physical thing. It is an agreement. And like all agreements, it has edges where it becomes slightly absurd. Reading time from the physical world doesn't always require a clock. Sometimes, it requires chemistry. Radiometric dating is one of the most elegant examples of time being inferred rather than measured directly. Certain radioactive elements decay at known, fixed rates. They lose particles and transform into other elements at a pace that is completely unaffected by temperature, pressure, chemistry, or any external condition. Uranium decays into lead. Carbon-14 decays into nitrogen. By measuring how much of an original element remains in a rock or an organic material, and comparing it to how much of the decay product has accumulated, scientists can calculate how much time has passed since that material was formed. The rock itself becomes a clock. The decay is the ticking. This is how we know the age of ancient fossils, of meteorites, of the Earth itself. Time has been running since long before anyone was here to measure it, and matter has been keeping the record. The most precise timekeeping devices ever created by human hands are atomic clocks. They work by measuring something far more stable than any mechanical movement or astronomical observation: the resonance frequency of atoms. A cesium atom, under the right conditions, oscillates between two energy states exactly 9,192,631,770 times per second. That number is not approximate. It is the definition. Since 1967, the international definition of 1 second has been exactly that many oscillations of a cesium-133 atom. Atomic clocks are so accurate that the best of them would not gain or lose a single second over hundreds of millions of years. They are not measuring time so much as they are instantiating it, giving it a physical anchor at a scale of precision that is almost impossible to intuitively grasp. But even atomic clocks, perfect as they are, require occasional correction. The Earth's rotation is not perfectly steady. It wobbles slightly, slows slightly, varies in ways that are real but irregular, caused by factors as large as the gravitational pull of the moon and as small as shifts in wind patterns and ocean currents. Over time, this means that the atomic definition of the second and the astronomical reality of the Earth's rotation drift slightly apart. The solution is the leap second, an extra second added to the global timescale occasionally, when the drift accumulates enough to require correction. It is a small, strange moment, a second that exists not because of physics but because of bookkeeping. The last few leap seconds have been controversial in the technology world, because adding an unexpected second to the global timescale can cause problems for network systems that assume time only moves forward in predictable increments. Time, even at this level of precision, is still partly a negotiation. The time that governs the internet, financial systems, telecommunications networks, and GPS satellites is not kept in any single place. It is constructed, assembled from the outputs of multiple atomic clocks around the world, averaged and weighted and distributed through networks to become a single agreed-upon global standard. The time on your phone right now is not the time your phone calculated independently. It is a time that was handed to your phone by a network, which received it from a server, which received it from an atomic clock, which was measuring the vibrations of individual atoms in a controlled laboratory somewhere. You are, in this moment, synchronized with a global infrastructure of extraordinary precision, and you probably haven't thought about it once today. And then physics arrived and changed the question entirely. For centuries, the assumption was that time was the backdrop, the stage on which everything else happened. Absolute, universal, ticking away at the same rate everywhere, for everyone, always. Isaac Newton described it this way, and for practical purposes, it worked perfectly well. But at the beginning of the 20th century, Albert Einstein proposed something that was, at first, almost impossible to accept: that time is not a backdrop. It is a dimension. It is woven into the fabric of space itself, inseparably, to form a single four-dimensional structure that physicists call spacetime. Time, in this picture, is not something you can pour like water or accumulate like savings. It is a coordinate, a direction in which events are located, just as left, right, and up, down, and forward, backward are coordinates in space. Just as you can ask where something is, you can ask when it is, and both questions are answered within the same geometric framework. An event doesn't just have a location in space. It has a location in spacetime, a set of 4 numbers that pins it precisely in the universe, 3 for space and 1 for time. This is not a metaphor. It is the mathematical structure of the universe as physics currently understands it. Space and time are not 2 separate things that happen to coexist. They are 2 aspects of a single thing, and they mix with each other in ways that depend on motion and gravity. Move faster through space, and you move slower through time. Sit in a stronger gravitational field, and time passes more slowly for you than for someone in a weaker one. The faster you travel, the more your spatial direction and your time direction blend together, trading off against each other in ways governed by precise equations. This is not speculation. It is measured, daily, in the corrections applied to GPS satellites. Those satellites are moving fast and are high above the Earth's gravitational field, and both of those factors affect the rate at which time passes for their onboard clocks. Without corrections based on Einstein's equations, GPS systems would accumulate errors of several kilometers per day. The relativity of time is not a philosophical curiosity. It is an engineering consideration. Space and time are woven together. That is the picture physics has given us, a universe in which the ground beneath your feet and the moment in which you stand on it are part of the same continuous fabric, curved by mass, stretched by motion, and experienced differently depending on where and how you move through it. The universe is not a stage with time running in the background. It is a 4-dimensional landscape, and every event that has ever occurred is a point within it, fixed, located, real. That is a thought worth carrying gently into the quiet of a late evening. You are not just somewhere. You are someone. And those 2 facts about you are not separate. They are the same fact, seen from 2 different directions. There is a version of the universe that feels intuitively correct. Space stretches out in 3 directions, left and right, forward and back, up and down. Time flows separately, steadily, universally. A clock in one city keeps the same time as a clock on the other side of the world, and both of them keep the same time as a clock orbiting the planet. The universe runs on a single rhythm, and every observer, no matter where they are or how fast they are moving, shares the same present moment. This picture is intuitive, deeply familiar, and almost entirely wrong. Einstein's theory of relativity did not just refine our understanding of time. It dismantled the version of time we thought we understood and replaced it with something that is, by any ordinary human measure, genuinely strange. Not strange in a vague or poetic sense, strange in a precise, mathematically exact, experimentally verified sense. The strangeness of relativistic time is not an interpretation. It is a measured fact about the universe we inhabit. Begin with spacetime geometry. In the framework Einstein gave us, the universe has 4 dimensions, and time is one of them. But time does not sit alongside the 3 spatial dimensions as an equal partner. It enters the equations differently, with a different mathematical sign, and this asymmetry is what gives time its distinctive character. In space, you can move in any direction. You can go left or right, forward or backward, up or down. you have complete freedom to choose your path. In time, you have no such freedom. You move in one direction only, forward, and you have no ability to stop or reverse. The geometry of spacetime encodes this asymmetry directly. Time is a dimension, but it is a dimension with a built-in direction, and that direction is not negotiable. This is sometimes called the arrow of time, and it is one of the deepest puzzles in all of physics. The fundamental equations of physics, the ones that describe how particles interact, how fields evolve, how forces operate, are almost entirely symmetric in time. Run them forward or backward, and they work equally well. And yet the universe we experience has a clear, unmistakable direction. The past is fixed. The future is open. Broken things do not reassemble. Heat flows from hot to cold, not the other way around. Somewhere between the time-symmetric laws of physics and the time-directed experience of reality, something gives time its arrow. Physicists believe the answer is connected to entropy, to the tendency of systems to move from order toward disorder, and to the extraordinarily low entropy state of the universe at the moment of the Big Bang. But the full explanation remains one of the most actively debated questions in theoretical physics. The speed of light is where the link between space and time becomes undeniable. Light travels at approximately 299,792 kilometers per second in a vacuum. This is not simply a fast speed. It is the maximum speed at which any information or any physical object can travel through the universe. Nothing with mass can reach it. Nothing can exceed it. And it is the same for every observer, regardless of how fast they themselves are moving. That last point is the one that breaks our intuitions most severely. If you are standing still and a car drives past you at 100 kilometers per hour, and someone in that car throws a ball forward at 50 kilometers per hour relative to the car, the ball is moving at 150 kilometers per hour relative to you. Speeds add together. This is ordinary, intuitive, and correct for slow objects. But light does not behave this way. If that same car were traveling at half the speed of light and turned on its headlights, the light from those headlights would still travel at exactly the speed of light relative to you, not 1.5 times the speed of light. It does not add. It cannot. The speed of light is a fixed ceiling in the structure of the universe, and maintaining that ceiling, for every observer, in every situation, requires time and space to adjust. They stretch and compress to preserve the constancy of light's speed. This is not a correction applied from outside. It is the geometry doing what it must. Which brings us to the heart of Einstein's great insight: time is relative. It is not a universal background process ticking away at the same rate for everyone. It is personal. It is local. It depends on how fast you are moving and how deep you are sitting in a gravitational field. Two observers moving relative to each other will measure time passing at different rates, and both of them will be correct. There is no third perspective from which one of them can be declared the true timekeeper. The universe has no master clock. This is time dilation, and it is real. A clock on a fast-moving spacecraft runs slower than a clock left behind on Earth, not because of any mechanical effect on the clock, but because time itself is passing more slowly for the traveler. If you were to travel at 90% of the speed of light for what felt to you like 1 year, you would return to Earth to find that considerably more than 1 year had passed for the people who stayed behind. The difference grows dramatically as speed approaches the speed of light. At very high speeds, a journey that takes years by the traveler's measure could correspond to decades or even centuries back home. This is not science fiction. It is a consequence of the geometry of spacetime, verified repeatedly in particle accelerators and with precision clocks flown on aircraft. Gravity does the same thing, through a related but distinct mechanism. Clocks run slower in stronger gravitational fields. A clock on the ground floor of a tall building runs very slightly slower than a clock on the top floor, because the ground floor is deeper in Earth's gravitational well. The difference is tiny, fractions of a microsecond per day. But atomic clocks can measure it, and it has been measured. If you live your entire life at sea level, you age very slightly more slowly than someone who spends their life at high altitude. The difference is too small to feel or notice, but it is real. Time flows at different rates at different depths in a gravitational field, and the effect becomes extreme near very massive objects. Near a black hole, where gravity is incomprehensibly strong, time slows to a crawl relative to distant observers. At the event horizon, the point of no return, time, as seen from the outside, appears to stop entirely. And there is no universal now. This is perhaps the most disorienting consequence of relativity, and the one that most directly contradicts everyday experience. We intuitively believe that there is a single present moment, a now that is shared by everyone everywhere, a universal instant that connects all observers across the universe. Relativity says this is an illusion. Two observers moving relative to each other will disagree about which events are simultaneous. An event that appears to be happening right now for one observer might appear to be in the past or the future for another observer moving at a different velocity. Neither is wrong. Simultaneity, the sharing of a present moment, is not absolute. It is relative to the observer. This means that now, as a universal concept, does not exist. There is no single slice through spacetime that all observers agree represents the present moment. There are only local nows, personal presence, defined by your own position and motion, and not shared exactly by anyone else in the universe. The present moment is real for you. It is just not universal. And even within your own local now, you are not seeing the universe as it actually is in this instant. You are seeing it as it was. Light takes time to travel. The light arriving at your eyes right now left its source some time ago, a fraction of a nanosecond for nearby objects, 8 minutes for the sun, for years for the nearest star. The stars you see on a clear night are not where they appear to be, and some of them may no longer exist. You are looking into the past with every glance at the sky. The further away an object is, the further back in time you are seeing. The most distant galaxies visible to our most powerful telescopes appear as they were billions of years ago, when the universe was young and the Earth did not exist. The night sky is not a snapshot of the universe now. It is a layered archive of many different nows, all arriving at your eyes simultaneously, all from different moments in the history of the cosmos. There is no way to see the real now, not at any distance greater than your immediate surroundings. the universe hides its present from any observer trying to see it from afar. By the time light reaches you, carrying information about a distant event, that event is already history. You are, always and inevitably, receiving news from the past. Einstein's relativity gave us a universe that is richer and stranger than the one we thought we lived in. Time is not a river flowing at the same rate everywhere. It is a fabric, curved by mass, stretched by motion, experienced differently by every observer depending on their path through the cosmos. It is personal. It is flexible. It is real in ways that simple clock time never captured. And yet, and this is worth holding on to, it still moves forward. For all its flexibility, for all the ways it bends and dilates and diverges between observers, time in our experience always flows in one direction. Memory accumulates. Causes precede effects. The future remains unwritten. Whatever time is, at the deepest level, it has given the universe a direction, and that direction is the one you have been moving in every moment of your life, including this one. There is something strange embedded in every photograph you have ever seen. Not strange in a troubling way, strange in the way that quiet truths often are, once you slow down enough to notice them. When you look at a photograph of a distant mountain, you are not seeing the mountain as it is now. You are seeing it as it was a tiny fraction of a second ago, because that is how long it took light to travel from the mountain's surface to the camera lens. The delay is too small to matter, too small to measure without extremely precise instruments. But it is real. The image is already history by the time it forms. Scale that up, and the effect becomes impossible to ignore. The sun you see in the sky is not the sun as it exists in this moment. It is the sun as it was 8 minutes ago, because that is how long its light takes to cross the distance between there and here. If the sun were to simply vanish right now, an impossible scenario, but a useful one, you would not know for 8 minutes. You would continue to see it, sitting in the sky, for 8 more minutes after it ceased to exist, because the light already on its way would still be traveling toward you. You would be watching something that was no longer there. The nearest star beyond our own sun, Proxima Centauri, is about 4 light-years away. The light arriving from it tonight left 4 years ago. The star you are seeing in that direction is a 4-year-old image. Some of the stars visible on a clear night are hundreds or thousands of light-years away. The light from them has been traveling since before any currently living person was born, in many cases, since before recorded history. And the most distant objects visible to our most powerful telescopes are so far away that their light has been traveling for billions of years. We are seeing them as they were when the universe was young, when galaxies were still forming, when the Earth did not yet exist. The universe, when you look outward, is not a view of now. It is a view of many different thens, arriving all at once. This is not a limitation of our instruments. It is a structural feature of a universe in which light has a finite speed and space has genuine scale. There is no way to see the distant universe as it currently is. The information simply has not arrived yet. In a very literal sense, the present state of the cosmos is invisible to anyone trying to observe it from afar. Every telescope is a time machine, and it only travels in one direction. As for traveling in the other direction, moving backward through time, or even meaningfully forward beyond the natural pace, physics is considerably less accommodating. The equations of general relativity do contain solutions that seem to permit closed time-like curves, paths through spacetime that loop back on themselves, theoretically allowing a traveler to return to their own past. But these solutions require conditions that are either physically impossible or so extreme as to be permanently beyond any conceivable technology. Traversable wormholes, if they exist at all, would require matter with negative energy density to hold them open, a property that may be fundamentally incompatible with the laws of physics. Traveling faster than light, which might in principle allow a form of backwards time travel, is forbidden by relativity for anything with mass. The universe seems to have arranged itself carefully to prevent paradoxes. Time travel to the past remains, for now and likely permanently, a mathematical curiosity rather than a physical possibility. Forward time travel, in a limited sense, is already real. Anything moving very fast ages more slowly relative to stationary observers, which means that a traveler on a sufficiently fast spacecraft would arrive at a future moment having experienced less elapsed time than the people who stayed behind. You travel forward through time at a different rate, effectively arriving in a future that has moved further ahead than you have. Particle accelerators observe this constantly. Unstable particles that should decay in microseconds survive for much longer when accelerated to near light speed, because time genuinely runs slower for them. This is not metaphor. It is measurement. But the deeper question, why does time run forward at all, for anyone, at any speed, is one that physics has circled for well over a century without fully resolving. The laws of physics, at the microscopic level, are almost perfectly symmetric in time. Write down the equations governing how two particles interact, and they work equally well whether you run time forward or backward. A film of two particles colliding and bouncing apart looks physically valid when played in reverse. There is no equation that says this particle can move forward but not backward in time. The microscopic laws are, to an extraordinary degree, indifferent to direction. And yet the macroscopic world, the world of everyday experience, is unmistakably asymmetric. Eggs break and do not unbreak. Ice melts into warm water and does not reassemble into ice cubes. Smoke rises from a fire and disperses into the air and never spontaneously reconcentrates and flows back into the wood. These processes go in one direction only, and the direction is always the same. Why? The answer, as best as physics can currently offer it, is entropy. Entropy is a measure of disorder, or more precisely, of the number of different microscopic arrangements that correspond to a given macroscopic state. A broken egg can be arranged in an enormous number of ways at the microscopic level. An intact egg has far fewer options. The molecules must be in just the right configuration to form a shell and a yolk and a white. Because there are vastly more ways to be broken than whole, a broken egg is enormously more probable than an intact one. Random processes, left to themselves, will almost always move toward higher entropy, toward greater disorder, simply because there are more disordered states available than ordered ones. Thermodynamics formalized this intuition into a law, the second law, which states that the total entropy of a closed system will never decrease over time. Energy spreads out. Order gives way to disorder. Heat flows from hot to cold. This law has a direction built into it. It is one of the only fundamental physical laws that distinguishes the future from the past. And it is this law, physicists believe, that gives time its arrow in our experience. The reason the future feels different from the past is that the future is, statistically, the direction of increasing entropy. But this raises a question that is quietly unsettling. Why was entropy so low to begin with? For entropy to increase over time, it must have started somewhere. And indeed it did. At the moment of the Big Bang, the universe began in a state of extraordinary, almost incomprehensible order, low entropy, highly structured, a single point of unimaginable density and temperature. Everything since then has been the gradual unfolding of that initial order into the increasingly complex, increasingly spread out universe we inhabit. The arrow of time, the reason past and future feel different, the reason broken eggs stay broken, ultimately traces back to the initial conditions of the universe itself. And that brings us to the beginning of time. The Big Bang was not an explosion in space. It was an expansion of space itself, the beginning of space, of matter, of energy, and of time. Before the Big Bang, in any physically meaningful sense, there was no before. Time did not exist and then begin. Time began with the beginning. Asking what happened before the Big Bang is, according to our best current understanding, like asking what is north of the North Pole. The question assumes a framework, a before, that did not yet exist at that moment. There is no answer, not because the answer is unknown, but because the question may not be well formed. This is one of the strangest facts about time. It has a beginning. Not just our measurement of it, not just our experience of it, but time itself, as a physical dimension, appears to have started approximately 13.8 billion years ago. Every moment that has ever occurred, every event in the history of the entire universe, fits within that span. And the universe has been expanding ever since, space itself growing, galaxies moving apart, the cosmos cooling from its original unimaginable heat into the vast, cold, structured universe it is today. This expansion is itself a way of measuring cosmic time. The further away a galaxy is, the faster it appears to be receding, and by measuring these recession velocities, by looking at the light from distant objects and reading the stretching that expansion has imprinted on that light, cosmologists can work backward through time and reconstruct the history of the universe. The expansion is a clock of sorts, a cosmic record of how much time has passed since the beginning. But cosmic time comes with its own uncertainties. The age of the universe, 13.8 billion years, is a measurement, not an exact known quantity. Different methods of measuring it have, in recent years, produced results that are close but not perfectly consistent, a discrepancy that cosmologists call the Hubble tension and are actively working to resolve. Even at the largest scales, even with the most powerful instruments ever built, our reading of cosmic time carries error bars. The universe is very old, and we are reading its age from clues it left for us in the structure of space itself. We are doing remarkably well. But we are also, still, doing our best. Somewhere between the quantum world and the cosmic one, Between the microscopic reversibility of physical laws and the vast one-way expansion of the universe, time acquires its direction, its scale, and its character. It begins at a singularity. It flows toward greater entropy. It carries everything in the universe forward together, stars and galaxies and living things and the thoughts you are having right now, all of them riding the same expansion, all of them moving in the same direction through the same four-dimensional fabric. You are part of something that has been unfolding for nearly 14 billion years. Every atom in your body was forged in stars that lived and died long before this planet existed. The time you are living in right now is a very small, very recent, very specific chapter in an incomprehensibly long story. And the story, as far as anyone can tell, is still very much in progress. At the largest scales the universe can offer, time and energy are not separate concerns. Mass and energy, which Einstein showed are interchangeable, two expressions of the same underlying quantity, curve spacetime. They bend the geometry of the universe the way a heavy object bends a stretched sheet. And where spacetime is curved, time flows differently. We have already seen this near planets and black holes, where gravity slows time measurably. But the same principle applies to the universe as a whole. The overall energy density of the cosmos, how much matter and energy is packed into each region of space, shapes the large-scale geometry of spacetime and therefore the nature of time itself at cosmic scales. In the early universe, when everything was compressed into an unimaginably small and hot region, the energy density was so extreme that the physics governing time was utterly unlike anything we experience today. The forces that are now distinct, gravity, electromagnetism, the nuclear forces, were unified into a single interaction at those temperatures. Time, in that environment, may not have behaved in any way we would recognize. As the universe expanded and cooled, things separated and structured themselves into the cosmos we inhabit now. The relative calm of the present universe, vast, cold, and mostly empty, is a very specific phase in a long story, and time in this phase has the qualities we have spent this entire evening exploring. Cosmologists use time as one of their primary mapping tools. The history of the universe is organized along a timeline, not arbitrarily, but because each era of cosmic history is defined by the physical conditions that prevailed during it. The first fraction of a second after the Big Bang saw the formation of quarks and the fundamental forces separating. The first few minutes produced the lightest atomic nuclei. Hundreds of thousands of years later, the universe cooled enough for electrons to settle into orbits around those nuclei, and space became transparent to light for the first time, releasing the radiation we now observe as the cosmic microwave background, the faint afterglow of the Big Bang that still fills the sky in every direction. Hundreds of millions of years after that, gravity gathered gas into the first stars. And so on, through billions of years of stellar birth and death, galaxy formation, and the slow construction of the structured universe we observe today. When cosmologists describe the universe, they describe it in time. Time is the axis along which the entire story is arranged. But what happens to time at the end of that story? This depends on how the universe ends, and physicists have more than one candidate. If the expansion of the universe continues accelerating, driven by the mysterious force called dark energy, the cosmos will grow increasingly cold and empty over trillions of years. Stars will exhaust their fuel and go dark. Black holes will eventually evaporate through a quantum process called Hawking radiation. The last structures will dissolve into a thin, featureless sea of radiation at near absolute zero temperature, a state sometimes called the heat death of the universe, or the Big Freeze. In this scenario, time does not exactly stop. It simply continues, emptily, through a universe in which nothing meaningful ever happens again. An endless, eventless expanse. Other models suggest different endings. If dark energy strengthens over time, it could eventually tear apart not just galaxies but solar systems, then planets, then atoms themselves, a scenario called the Big Rip, in which the expansion accelerates without limit until spacetime itself is shredded. Time, in this model, would end abruptly and completely, at a finite moment in the future. There are also models involving a big crunch, or reversal of expansion, with the universe eventually collapsing back on itself. Whether time would end in such a collapse, or somehow continue through it into a new expansion, remains an open question. Some cosmologists have proposed cyclic models of the universe, in which big bangs follow big crunches in an endless sequence, with time persisting through each cycle. In some of these models, what we call the beginning of time may itself have been a transition from a previous state rather than a true beginning. The honest answer is that we do not know how time ends, or whether it ends at all. We know the universe has a direction. We know it has a history. What it has by way of a conclusion remains genuinely uncertain. And then, below all of this, below cosmology, below relativity, below atoms and molecules and even the particles that compose them, there is a level at which our understanding of time becomes not just uncertain but philosophically strange in ways that have not yet been resolved. Welcome to quantum mechanics, and to what may be the deepest edge of what physics currently knows about time. The Planck time is the smallest unit of time that standard physics can meaningfully describe. It is approximately 5.39 times 10 to the power of negative 44 seconds, a number so small that writing it out as a decimal would require 43 zeros after the decimal point before you reach the first significant digit. At this scale, the concepts that we use to describe time in everyday physics, duration, sequence, the smooth flow from one moment to the next, may cease to apply altogether. Below the Planck scale, our current theories produce results that are either undefined or infinitely large, which is physics's way of saying that the theory has reached the edge of its own validity and is no longer describing reality reliably. What happens at or below the Planck scale is genuinely unknown. But several approaches to quantum gravity, the still incomplete effort to reconcile quantum mechanics with general relativity, suggest that time at this scale is not smooth and continuous. It may be granular. It may be composed of discrete units, like pixels in an image, rather than the seamless flow we experience at human scales. If this is correct, then between two adjacent Planck moments there is nothing, not a shorter time, not a smaller gap, but simply no meaningful interval at all. Time would have a minimum unit, a smallest possible tick, below which the concept of before and after loses its meaning. This is deeply counterintuitive. We experience time as perfectly continuous, a smooth river, not a string of beads. But our experience operates at scales billions of times larger than the Planck length. The granularity, if it exists, would be completely invisible at any scale we can currently probe. It would be as invisible to us as the atomic structure of water is to a person swimming in the ocean. The smoothness is real at our scale. Whether it persists all the way down is a question that current physics cannot answer. At quantum scales, even without reaching the Planck limit, time behaves oddly. In quantum mechanics, particles do not have definite positions or momenta until they are measured. They exist in superpositions of many possible states simultaneously. There is reason to believe that time may be subject to similar blurring. Rather than existing at a single precise moment, a quantum event may be spread across a range of times in a way that has no classical analog. The crisp, exact instant at which something happens may be, at the quantum level, fundamentally fuzzy. Not because of any limitation in our instruments, but because definiteness itself does not apply at that scale. Quantum entanglement adds another layer of strangeness. When two particles are entangled, measuring one of them instantly determines the state of the other, regardless of the distance between them. This connection appears to be instantaneous, which creates a deep tension with relativity's insistence that no information can travel faster than light. The resolution to this tension is subtle and still debated, but it touches on time in a fundamental way. Entanglement seems to correlate events across space in ways that do not fit neatly into a picture where time is a simple sequence of local moments. Some physicists have proposed that entanglement is not just a relationship between particles but a relationship that is partly constitutive of spacetime itself, that the geometric structure of space, and perhaps time, emerges from the pattern of quantum entanglement in the universe. Space and time, in this view, are not the fundamental stage on which quantum events play out. They are built from quantum relationships, and time is an emergent feature of a deeper, timeless structure. This leads to perhaps the most surprising possibility of all. In certain formulations of quantum gravity, most notably the Wheeler-DeWitt equation, which attempts to describe the quantum state of the entire universe, time does not appear. The equation describing the universe at its most fundamental level has no time variable. There is no one in the equation. The universe, at this level of description, simply is a static, timeless quantum state in which what we experience as the flow of time is somehow encoded, but not as an explicit ingredient. Time, in this picture, is not fundamental. It is emergent. It is what happens when a timeless quantum system is observed from within, when part of the system uses another part as a clock and generates, from that relationship, the experience of moments following one another. This is not a settled conclusion. It is an active area of theoretical exploration, and there are physicists who find it compelling and physicists who reject it entirely. But it represents a genuine possibility that physics is currently wrestling with, that time as we experience it, the flowing, directional, ever-present medium of all our experience, may be something that emerges from a deeper reality that does not itself contain time at all. Sit with that for a moment. The sensation of time passing that you are experiencing right now, the quiet sense of this moment giving way to the next, may be something that arises at the level of complex, interacting systems, the way temperature arises from the motion of molecules. No single molecule has a temperature, but many molecules moving together produce something that can be measured as heat. Perhaps no single quantum of reality has a time, but many quantum relationships interacting together produce something that, at our scale, we experience as the present moment. If that is true, then time is not the container that holds everything else. It is something that everything else, taken together, produces. And you are part of that everything. Your awareness of this moment, your sense of now giving way to now, your quiet presence in this particular stretch of the night, all of it may be, in some deep and beautiful sense, time generating itself through the act of being observed from within. That is where physics currently stands at its frontier. Not with certainty, not with clean answers, but with the honest, open-handed acknowledgement that time, the most familiar thing in all of human experience, remains, at its deepest level, one of the greatest mysteries the universe has ever offered to anyone willing to look closely enough to notice. Physics has a habit of doing something quietly radical. It begins with a question that seems straightforward, follows the mathematics wherever it leads, and arrives somewhere that makes the original question feel almost naive. That is exactly what has happened with time. We began this exploration with something everyone understands. Time orders events. Time is what keeps everything from happening at once. Time is the medium of memory, of music, of aging, of history. These are real and true observations. And they remain true. But physics, pressed to its limits, has begun to suggest something that sits uncomfortably alongside all of them, that time, at the deepest level of reality, may not be a fundamental feature of the universe at all. This is not a casual philosophical speculation. It emerges directly from the mathematics. When physicists attempt to write down an equation that describes the quantum state of the entire universe, not just a particle, not just a field, but everything, they find that time disappears from the equation. The Wheeler-DeWitt equation, which represents one of the most serious attempts to marry quantum mechanics with general relativity, contains no time variable. It describes a universe that is, in a mathematical sense, static, frozen. A timeless configuration of everything that is, without any external clock ticking away in the background to measure its evolution. This is not a quirk or an error. It is a deep consequence of how the mathematics works when you try to apply quantum theory to gravity at the level of the whole universe. Gravity, in general relativity, is the geometry of spacetime. It is not something that happens in time, it is part of time's structure. When you try to quantize gravity, to bring it into the quantum framework, the time coordinate gets absorbed into the structure of the equation and vanishes from view. What you are left with is a description of the universe that has no moment, no sequence, no flow. Just a timeless quantum state. What does that mean for the time you experience? Theorists like Julian Barber, Carlo Rovelli, and others have spent decades exploring this question, and their answers, while different in detail, converge on a similar theme. Time as we experience it may be emergent. It may arise from relationships between parts of that timeless quantum state, the way that temperature arises from molecular motion. No single molecule is hot or cold, but many molecules moving and interacting produce something measurable as temperature. Perhaps no single quantum configuration of the universe contains time. But when subsystems of that configuration interact, when one part of the universe uses another part as a reference, as a clock, what emerges from that relationship is the experience of time passing. In some geometric descriptions of reality, time is not required as a separate input at all. The full history of a system, every configuration it passes through, can be described as a shape in a higher dimensional space, where what we call time is simply one of the dimensions that defines that shape. The shape exists. It does not unfold. The unfolding is our experience of moving through it, not a property of the shape itself. Time, in this view, is a direction in a geometry that simply is, rather than a process that actually flows. And here the philosophy begins to press against the physics in interesting ways. For time to be a feature of objects in the world, for things to age, to change, to move, time must be something that acts on them, or that they exist within. But if time is emergent, if it arises from relationships rather than being built into the fabric of things, then it is not innate to any object in isolation. A single particle, considered entirely on its own, does not age. It does not have a history. It simply is, in whatever state it is in. It is only when particles interact, when systems entangle, when information passes between parts of the universe, that something like time begins to emerge from the relationships. Time, in this picture, is not a property of things. It is a property of the connections between things. This has profound implications for one of the oldest debates in philosophy, free will. The connection between time and free will is not incidental. Free will, the sense that your choices are genuinely open, that the future is not already fixed, requires that the future be different in kind from the past. It requires that what has not yet happened is genuinely undetermined, not merely unknown. If time is real, if the future is genuinely open in some physical sense, then free will has at least a conceptual home in the structure of the universe. But if the universe is, at its deepest level, a timeless geometric object in which past, present, and future all equally exist as fixed points in a four-dimensional structure, what physicists call the block universe, then the future is already there, already real, simply not yet reached by your experience. In that case, the openness you feel when you make a choice may be, in some sense, an artifact of your position in the geometry rather than a genuine feature of the universe. This is not a settled question. Philosophers and physicists disagree about it seriously and thoughtfully. Some argue that the block universe is fully compatible with meaningful free will, because what matters is the structure of decision-making processes, not whether the outcome is predetermined. Others find the timeless block universe incompatible with any genuine notion of agency. The debate is live, and the answer, if there is one, matters enormously for how we understand ourselves as beings in the world. Time also turns out to be deeply connected to complexity. In physics and information theory, complexity, the degree to which a system contains structured, non-redundant information, tends to increase with time, at least for a while. Simple initial conditions evolve, under time, into intricate structures, atoms into molecules, molecules into cells, cells into organisms, organisms into ecosystems and civilizations. The relationship between time and the growth of complexity is not coincidental. It is governed by the same thermodynamic principles that give time its direction. Entropy increases, but on the way to maximum disorder, interesting structures can form, eddies of order in a stream flowing toward chaos. We are among those eddies. Life, thought, culture, science, all of it is complexity that time has made possible, drawn out of simple beginnings by the relentless forward motion of entropy. But is the flow of time itself real, or is it an illusion? This is the question that sits at the center of everything. The physicist Julian Barbour has argued at length that time does not flow. What exists, in his view, is a vast collection of what he calls nows, momentary configurations of the universe, each one complete in itself, each one containing the appearance of memory and the appearance of a past, but none of them actually connected by any flowing present. The sense of time passing, in this view, is built into the structure of each now. Each moment contains within it the traces of what looks like a history. But the flowing itself, the actual passage from one moment to the next, is something that happens only in experience, not in the underlying physics. Carlo Rovelli, approaching the same question from a different direction, has argued that time as we experience it, with its flow, its directionality, its sense of the present, is a product of our particular position as thermal beings embedded in a world far from thermodynamic equilibrium. We experience time flowing because entropy is increasing around us, because we have memories of the past and not the future, because our neural processes are irreversible. But these are features of our experience, not necessarily features of the fundamental laws. At the fundamental level, time may be simply one of many dimensions of a relational structure, no more special, no more flowing, than the spatial dimensions we navigate without any sense of being carried through them. And yet, the experience of time is the most immediate and undeniable feature of conscious existence. Whatever physics says about the fundamental structure of reality, the sense of now, of being here, in this moment, with this moment giving way to the next, is the most vivid thing about being alive. You cannot step outside it. You cannot observe it from a distance. You are immersed in it completely, every moment of your conscious life. Perhaps the most honest position available to us, at this particular moment in the history of human understanding, is this: time is real as an experience, real as a feature of the world we inhabit at human scales, real in its effects on matter and energy and living things. Whether it is fundamental, whether it is built into the deepest structure of reality, is genuinely uncertain. The equations that have proven most successful at describing the universe at its smallest scales seem to be telling us that time is not among the primary ingredients. It is something that emerges, something that arises, something that the universe produces from deeper components rather than begins with. If time is an emergent illusion, it is the most consequential illusion in all of existence. It is the illusion inside which every experience occurs, every decision is made, every life is lived. It is the illusion that makes loss painful and anticipation sweet and memory possible and love meaningful. An illusion that rich, that universal, that inescapable, it begins to seem like a strange use of the word illusion. Perhaps it is better to say that time is real at the level at which reality matters to us, and that what lies beneath that level is something we are only beginning to find language for. The universe, it turns out, is not obligated to be easily described. It is not required to conform to the categories that evolved minds find intuitive. Time may be one of those places where the territory is genuinely stranger than any map we have yet drawn of it. Not because we have failed to understand it, but because understanding it has led us somewhere that understanding alone cannot quite reach. And so here we are, on the other side of a very long journey through the nature of time, from the familiar rhythm of a morning waking up, through the elastic corridors of memory and psychology, through the precision of atomic clocks and the curvature of spacetime, through the quantum frontier where time dissolves into relationship and geometry, to this final, quiet, genuinely open question of whether time flows at all. No clean answer. No final resolution. Just the honest, generous mystery of a universe that has been unfolding for nearly 14 billion years and has not yet finished revealing what it is. You have been traveling through time this entire evening, moving forward, as you always do, at the only speed available to you. Whatever time is, at its deepest level, it has carried you here. To this moment. To this particular point in the long story of everything. That is, by any measure, a remarkable place to be. After everything, after the relativity and the entropy, the quantum equations and the dissolving definitions, the cosmic timelines and the philosophical edges, time brings us back, quietly and inevitably, to the human scale. To the small, tender, ordinary ways that time makes itself felt in a life. Consider the time capsule. It is one of the most quietly poignant things human beings do. Somewhere, right now, there are metal boxes and sealed containers buried in schoolyards and courthouse lawns and city parks, filled with photographs and newspapers and handwritten letters and objects that someone chose to preserve. Not for themselves. For strangers. For people who are not yet born, or who are children now and will be old by the time the capsule is opened. The act of burying a time capsule is an act of extraordinary faith, faith that time will continue, that there will be people on the other side of it worth communicating with, that the things which feel meaningful now will still be recognizable as meaningful in 20 or 50 or 100 years. It is a love letter written to the future from the present, folded up and placed underground to wait. No other animal does this. It requires an understanding of time that is uniquely, specifically human. Nostalgia is the emotional counterpart to the time capsule, not a message sent forward, but a feeling that pulls backward. It is the bittersweet ache of a past moment reasserting itself in the present, arriving unexpectedly through a smell, a song, the particular quality of afternoon light in a certain season. Nostalgia is time making itself felt as loss, not the loss of something bad, but the loss of something good, something that was real and warm and is now only accessible through memory. The word itself comes from the Greek, nostos, meaning homecoming, and algos, meaning pain. The pain of trying to come home to a place that exists only in the past. Every human being who has ever loved anything has felt it. It is one of time's most specific emotional signatures, the proof that the past was real, and that it mattered. Birthdays are how we mark the passage of time through a single life. They are personal anniversaries of existence, a moment once a year when the calendar returns to where it was on the day you arrived in the world, and you are invited to notice how far you have traveled since then. Different cultures celebrate them differently, and some do not celebrate them in the familiar way at all. But the impulse to mark the orbit, to acknowledge that another year of time has passed through you and that you are different for it, is nearly universal. A birthday is a small ceremony in honor of time and survival. It says, "I was here then, and I am still here now," and something about that is worth pausing for. Time is also what makes you singular in space. You cannot be in two places at once, not because of any lack of willpower or technology, but because your physical existence is a single continuous thread moving through spacetime. You occupy one location at each moment, and then another, tracing a path that is uniquely yours through the four-dimensional fabric of the universe. That path does not branch. It does not duplicate. It moves forward in one direction, through one set of moments, and the experiences you have along it are available to no one else in exactly the form you have them. Your life, in this sense, is a specific trajectory, irreplaceable, unrepeatable, written once and not revised. Even the most mundane infrastructure of modern life depends on time in ways so fundamental that we rarely notice. Traffic lights work because they operate on coordinated timing, green here, red there, in a sequence calibrated to move the maximum number of vehicles through an intersection with the minimum number of collisions. If timing coordination failed, if lights switched randomly or independently, the result would be chaos almost immediately. The entire system of urban traffic flow is a time-dependent structure. It is time, made into infrastructure, made into the safe movement of millions of people through shared space every single day. Films have runtimes. This seems obvious, but it is worth sitting with for a moment. A film is not just a story, it is a story delivered across a specific duration, paced deliberately, with moments that breathe and moments that accelerate, silences that mean something and cuts that create meaning by what they juxtapose. A great filmmaker is a master of time, knowing how long to hold a shot, when to cut, how to use rhythm and pacing to create emotional states in an audience. The runtime is not a technical detail. It is the temporal container that gives the experience its shape. Cinema is, at its core, a time-based art form, and the skill of the filmmaker is largely the skill of managing a viewer's experience of duration. Even the machines we build require time in their deepest design. A robot navigating a room must plan its actions in layers, immediate reactions to sudden obstacles, medium-term planning for sequences of movements, longer-term strategy for reaching a goal. Each layer operates on a different timescale, and the robot must coordinate between them continuously. Artificial intelligence systems that make decisions, whether in robotics or finance or medicine, require temporal models, representations of how the world changes over time and how actions taken now will affect states in the future. Time is not just a background condition for intelligent systems. It is a structural requirement of how intelligence works. To think is, in part, to navigate time, to use knowledge of the past to model the present and anticipate the future. We build that into our machines because we cannot build intelligence without it. Urgency is what happens when the future becomes close enough to press on the present. It is the feeling that time is running out, that a gap between now and some necessary moment is closing faster than comfort allows. Urgency is uncomfortable by design. It is a motivational state produced by the awareness of time, a signal from the mind that the ordinary pace of things is insufficient for the current situation. In small doses, it is useful. It moves us to act, to prioritize, to focus. In large and chronic doses, it is exhausting, because it keeps the nervous system in a state of vigilance that was designed for short emergencies rather than long stretches of modern life. Urgency is time experienced as pressure, and the relationship between the two reveals how deeply time is woven into the emotional life of any creature that can anticipate a future. All of these things, time capsules and nostalgia and birthdays and traffic lights and film runtimes and robotic planning and the feeling of urgency, are expressions of the same underlying reality. Time is the medium. We are creatures who live in it, who are shaped by it, who organize our entire civilization around managing it, measuring it, honoring it, and occasionally being overwhelmed by it. And we do all of this while still, after all these centuries of philosophy and physics and careful measurement, not fully understanding what it is. That is the final, extraordinary truth about time. It is the most intimate thing in all of existence, closer to you than anything else, present in every moment of your life, the very substance of your experience. And it remains, despite everything, genuinely mysterious. Not mysterious in a way that suggests we have simply not looked hard enough, or that the right experiment is just around the corner. Mysterious in a deeper sense, in the sense that the closer physics and philosophy press toward it, the more it seems to recede from any final, clean definition. We can measure it with atomic precision. We can describe how it curves near massive objects and slows near the speed of light. We can trace it back to within fractions of a second of the Big Bang. And yet the question of what time fundamentally is, whether it flows or simply is, whether it is real or emergent, whether it is a dimension or a relationship or an illusion generated by the structure of experience, remains genuinely, honestly open. There is something deeply comforting about that, if you let it be. It means that the universe has not yet been fully explained. That the questions which matter most, the ones that touch the fabric of existence itself, are still alive, still being asked, still drawing the best human minds into the same wondering that you are doing right now, in this quiet hour, at the end of this long day. You are made of time. Not metaphorically, literally. The atoms in your body have been through billions of years of cosmic history to arrive in the configuration that is you, right now, in this moment. The experiences that make you who you are exist only because time made them possible, because one thing led to another, because you grew and learned and changed, because the past accumulated into the present and the present is continuously becoming the past. You are a creature of time in the most complete sense imaginable. And yet time has not finished with you. Whatever hours and years remain in your particular trajectory through space-time, they are genuinely open. Not because physics necessarily guarantees it, but because the future has not yet been experienced, and experience is where the meaning lives. The past is real and fixed in yours. The future is unknown and approaching. And right now, In this exact moment, this fragile, fleeting, paper-thin now, you are exactly at the edge between the two. That is where you always are. That is where everyone always is. And somehow, across all the complexity and all the mystery and all the unanswered questions about what time truly is at its deepest level, that simple fact is enough. You are here. The moment is happening. And whatever time turns out to be, it has brought you to this point, in this night, with everything still possible. That is, when you stop to feel it, a rather wonderful thing.